Okay, 9.3 relative rates of growth. So, this is what you need to really remember when you're figuring out the relative rates of growth. If F grows faster than G as X approaches infinity, the limit as X approaches infinity of F of X over G of X is going to equal infinity. If G grows slower than F, then the limit of G of X over F of X as X approaches infinity will equal 0. So if it grows faster, you're going to get infinity. If it grows slower, you're going to get 0. And if F and G grow at the same rate, you're going to actually find a limit. The limit as X approaches infinity of F of X over G of X will actually equal some number, some limit. So, all you have to remember, if it grows faster, you're going to get infinity. If it grows slower, you're going to get 0. And if it grows the same, you're going to come up with some number. I'm going to give you 4 examples and then show you one other rule that you have to need to know at the end. Here's the first problem. You're going to compare e to the x and x squared as x is approaching infinity. You're going to prove that the function e to the x grows faster than x squared. So, you do the limit as x approaches infinity of e to the x over x squared. I'm going to use L'Hopital's rule, and I'm going to find, I'm not going to keep writing now. I'm going to find the derivative of e to the x, which is e to the x. I'm going to find the derivative of x squared, which is 2x. I'm going to do it again. The derivative of e to the x is e to the x, and the derivative of 2x is 2. Okay, as x is getting bigger and bigger and bigger, think about it, as e is 2.718, if it keeps getting bigger and bigger and bigger, divided by 2, it's getting closer and closer to infinity. I just showed you that the function e to the x grows faster than x squared because my answer ends up being infinity. Number 2. The natural log of x, compare that with x and x squared as x approaches infinity. So, the limit as x approaches infinity of the natural log of x, and I'm going to do the x first. So I'm going to do these 2 first. Okay, so I'm going to find the derivative. The derivative of the natural log of x is 1 over x, and the derivative of x is 1, which really just makes 1 over x. And as x is getting bigger and bigger and bigger, it's getting closer and closer to 0. Now I'm going to do the limit as x approaches infinity of the natural log of x over x squared. And all I'm going to do is break this up into the natural log of x times 1 over x. Instead of doing L'Hopital's rule, I'm just going to show you another way you can do this by breaking it up. We just did the first one. We know that the first one ends up going to 0. And as x is approaching infinity, this one also gets closer to 0. And 0 times 0 equals 0. Okay, the next one. So, if when you get 0, you know what you get, right? That means it goes slower, because you ended up getting 0. Okay, let's do another one. Let's do number 3. Show that x grows at the same rate as x plus sine of x as x approaches infinity. The limit as x approaches infinity, show that x grows at the same rate as x plus the sine of x. I'm going to put x plus the sine of x all over x. And I'm just going to simplify it. I can put this over this and this over this, which makes 1 plus sine of x over x. And this one's automatically 1. And you remember all the way back, remember what the sine of x over x graph looks like from chapter 2. Okay, look on page 60 in your book, and you'll see it. You'll remember what that graph looks like. It looks like this, and then it like kind of goes like that, and then it goes like that. And as x is getting closer and closer to infinity, it's definitely getting closer and closer to 0. 1 plus 0 equals 1. Since you ended up with a number and not 0 or infinity, that means they're growing at the same rate. Okay, last part. The last part explains the last rule on page 459. On page 459 explains this rule. I'm just going to write it out. If f grows at the same rate as g as x approaches infinity, and if g grows at the same rate as h as x approaches infinity, then f grows at the same rate as h as x approaches infinity. Okay, if f grows at the same rate as g, and g grows at the same rate as h, then process of elimination says that f must grow at the same rate as h. So I'm going to show you one. Last problem. If f of x equals the square root of x squared plus 5, and g of x equals 2 squared of x minus 1 raised to the second, and h of x equals x. You want to show that f grows at the same rate as x is approaching infinity. So I'm going to start with the first part, the a part, and I'm going to show the limit as x is approaching infinity of f of x over h of x. Okay, this is kind of confusing, so kind of watch carefully. F of x is the square root of x squared plus 5 over x. I don't think we've ever done this before, so kind of watch carefully. Do you notice that the top has the square root? You can put the bottom also in terms of square root just by doing this. The square root of x squared plus 5 over the square root of x squared. The square root of x squared and x mean exactly the same thing, but now what you did was you can write the whole thing under a square root now and have x squared plus 5 over x squared. They want you to do this a lot. So again, the square root of x squared is the same thing as x. You can do that. And then you can write it as 1. Now you can split it up and write it as x squared over x squared is 1 plus 5 over x squared. And as x is getting bigger and bigger, this part is getting closer and closer to 0. So the square root of 1 is 1. Okay, now the next part, I'm going to do the limit as x approaches infinity, and I'm going to do g of x over h of x. And that is going to be 2 square root of x minus 1 squared all over h of x, which is x. Okay, how do you make them both squares? You go 2 square root of x minus 1 squared, but how do you make this using squares? All you do is put the square root of x squared, and that makes exactly x. Now that they're both squared, I can write it as 2 square root of x minus 1 all over the square root of x. All of that can be squared, which simplifies to, I can put this together first, which makes 2. Then I can put this together, which makes 1 over the square root of x, and I can square it. And then, as x is getting closer and closer to infinity, this part right here will get closer and closer to 0, and 2 squared is going to equal 4. Okay, now comes that formula, and the formula, you can look, is on right underneath that on page 459, and this is the rule. If the limit as x approaches infinity of f divided by h times h divided by g, like I said up there, the h's should cancel each other out and you're just left at f over g. So a was this part and b is kind of this part. I'll tell you about it in a second. So all you do is, I found the answer to the a, and the answer to the a was 1. And I found the answer to, look up here, g divided by h, but they want h divided by g, so I need to change my 4 to 1/4. All I do is I multiply the two numbers together. My final answer is 1/4.